So this is it. This is the end. This will be the last one until after Thanksgiving break. Last screencast you have to watch. Woo! So anyway, let's talk about letter D. So it says the following methanoate ion, HCO2- reacts with water to form methanoic acid and a hydroxide ion, shown as the following equation. So that kind of makes this then a base, because it forms a higher concentration of OH ion. So that's, good to know. Given that OH is this concentration in a solution, which means that we're at equilibrium, the OH concentration is 4.18 times 10 to the negative 6. That's going to be important in a 0.309. So I put the same equation down here at the bottom. The value of what we're looking for, the value of Kb. Now here's what we know about Kb. Kb is going to be then the concentration of OH minus times the concentration of HCO2H, like that. That's an odd way to write it, but that's how they write it. And then it will be obviously all over the concentration of HCO2 with a minus, like that. So that's our equation that we're going to use. We don't know what the Kb is yet. That's what we're going to find. We have part of it already. We know that this is the concentration of hydroxide, but it also should be the concentration of something else. So let's find out. So I have I, C, and E, initial change in equilibrium. We know the initial is 0.309 to start this. This is of sodium methanoate. The sodium part is, again, a spectator ion, so it doesn't show up anywhere, so don't be confused by that. So that just means that 0.309 molar concentration, and of course we don't do anything with that, is the HCO2 minus. And then we don't know what this is. We think it's going to be 0 to start, plus X. It's the same thing we've been doing all along. This will be minus X, so this is 0.309 minus X, X, and X. Now all we're going to do is substitute in what we know. Here's what we know. We know that, where's it at here? 4.18 times 10 to the negative 6th is what we end up with for X. So we know that already. Okay, we know that, and that means that if we produce this amount of hydroxide ion, we're also producing this amount of methanoic acid. So that means 4.18 times 10 to the negative 6th for both of these, because it's X and X. So, okay, so that makes sense to us. Notice how small times 10 to the negative 6th this is compared to 0.309. So that means, as always, for this chapter, we can get rid of the minus X part. So all we have to do now is plug it into our equation. Let me get some more room. We're going to plug it into our equation, Kb. Oh, by the way, Kb is for bases. Nothing changes. We do exactly the same thing as we did before. Just like it's Ka, it makes no difference. I'm going to show you where it actually makes a difference. I'll show you that in 1 second. That's the next part of the problem. But for this right here, HCO2 minus. This one's a minus. I wrote that real ugly anyway. Oh boy, this is not close. Okay, so HCO2 minus, like that. Now, all I'm going to do is I'm going to put in the terms, the amounts for each one of these. What you're going to see is that 4.18 times 10 to the negative 6th shows up twice, so I square that, and then all of that is divided by 0.309, like this. Okay, now what does that equal? When I take that number divided by that number, I should, for the Kb, then get 5.65 times 10 to the negative 11. Okay, 5.65 times 10 to the negative 11. Now we're not done yet, because it still asks us, let's keep going here, it still asks us, so the value for Kb is 5.65 times 10 to the negative 11. Okay, now here's what we know. We know that I'm going to have to do E afterwards. So I'm going to do II in red, and then I'll do letter E in blue. So for II, let's continue on. I know that Kw equals Kb times Ka. That's what it equals. You can check that out. If I know what Kw is, I know that 1 times 10 to the negative 14th is Kw. I know Ka then is, where are we at here? So I'm going to take the Kw divided by Kb, which is 5.65 times 10 to the negative 11, and then whatever that equals should be Ka. So that is 1.77 times 10 to the negative 4th. Okay, that is what Ka is then. Okay, so Kw equals Kb times Ka, or Ka times Kb. I solved for Ka, which is Kw. That's this right here, Kw, divided by Kb. And that gives me the Ka. Okay? And then the last part to this says, which acid is stronger, propionic acid or methanoic acid? So let's take a look. Methanoic acid, the Ka is 1.77 times 10 to the negative 4th. Propionic acid, the Ka is 1.34 times 10 to the negative 5th, I believe. Yeah. So that means that meth is a stronger acid because it's larger Ka. So the Ka's, if it's larger than propionic acid, then meth is the stronger acid. So the larger Ka means a stronger acid. So this one's going to be stronger. Everybody knew meth was stronger anyway. Okay, guys, that's it. Enjoy your Thanksgiving break.